My name is Shashi Kumar, and I shall be the host for the day. I run an organization named Salcom, which is one of the top companies in the area of mobile phone accessories and components. We do have a significant presence in India and overseas. I have been associated with Dr. Kalam's foundation for quite some time now, to be a very small part in implementing the vision of our great scientist, Dr. Kalam. I consider this as a very personal privilege to be in the midst of you today. Thank you again for joining us. And to all our audience who are watching this session live, a very warm welcome. And as much as you are eager to hear from our speakers, I am very eager to. The theme title, Innovation and Product Development with Green Energy, is so apt for the era that we live in today. While the pandemic has brought the whole world to its knees, the result of this, we all understand the importance of preserving our nature. Innovation is the key, not only for companies, but also for countries. So the countries do not innovate, do not flourish. So Israel is one such example, when we talk about innovation, given the limited resources that they have, and Japan is another country too. Product development with a focus on green energy shall help the planet to sustain. So let's hear from our eminent speakers on their thoughts, ideas, and insights that they have to offer us during this webinar, focused on innovation and product development with green energy as the key focus. This is a 2 hours webinar, and we shall have 30 minutes Q&A session as well at the end of this webinar. And now, as our first eminent speaker, I would like to introduce Professor Ashok Jhunjhunwala. So Professor Ashok Jhunjhunwala is a professor at IIT Madras. And
yeah, I think we can introduce ourselves. No point in it in a webinar. It takes a long time and doesn't do the ball right. So I will start and try to end in time. In fact, sooner than that. I'm going to give a relatively short talk, basically titled, How Far Can We Go with Green Energy in India? And I will, of course, talk about electricity. That will be my primary talk. I'll not talk much about cooking, but we know that electricity can be used for cooking. We need to move towards that. And then for transport. On cooking, I could give another talk at some other point of time, but today I will talk primarily about electricity and transport. Now, I think most people know that today's solar-based electricity, to produce electricity and supply, it costs about 2.50 rupee per unit of electricity per kilowatt hour. This has been the going rate for last several years. It keeps on fluctuating a bit, but more or less this is the rate. Similarly, wind-based electricity is 2.50 rupee per kilowatt hour. Incidentally, coal-based power plant also cost the electricity from coal-based is roughly the same. Of course, depending on whether it's old plant or new plant, cost can go up and down, but that is the order of magnitude. On the other hand, oil and gas-based plants cost much higher, 16 rupees or 12 rupees per unit. So the question that is there, that we know that solar and wind are renewables and it can really create, it has zero pollution. So what stops us from going 100% renewable, solar and wind? We have enough solar and wind. In fact, if you look at solar around the country, I mean, we have even a very small area part of Rajasthan can create enough solar for the whole country. And we have plenty of wind, coastal wind, ocean. It can also be there in the ocean. So we have plenty of solar and wind. And it costs approximately 2.50 rupee per unit. The problem is solar and wind is not available 24/7, whereas coal is. So output cannot be controlled by human beings like the coal-based electricity. So what is the thing that we need to do and what has been done over the years? The first thing I think many of you will know, and if you don't know, please learn this, that electricity, once it is produced, it has to be used immediately. If it is not used, it's gone. So the question is, there is a huge number of plants which are generating, there is a generation going on, and demand, lots of people are using, I'm using it for this laptop and all kinds of things. Question is, how does every instant generation it becomes equal to the demand? If power produced is less than the demand, well, that used to be the scenario in India till few years back, and we used to have power cuts and load shedding. In select areas, the power will be cut off. If demand is less than the power produced, which is currently today so, then you have to reduce power production, so that demand matches the load, the generation. But it is possible to do it instantaneously in oil and gas plant. With some delay, it can be done in coal plant. I mean, with hour and a half, even less, 45 minutes delay, it can be done. But for solar and wind, that is not in our hands. It cannot be increased or decreased. And of course, in that way, the excess power can be dumped. Over the last 10 years, there has been a lot of work of alternatively used demand management. The whole concept of smart grids came from demand management. The demand management basically said increase, decrease, or postpone use of power to match generation. So you can increase demand by actually suddenly turn on your washing machine. If everyone turns on, it increases demand. Decreases demand, well, right now there is a shortage, let everyone start using it less. Or postpone, saying that instead of using it now, I'll use it 4 hours later on. Now, how is that to be implemented? Because all of us are users, millions, hundreds of millions of users. How do you really manage this? By actually giving us incentive, saying that if there is a shortage, I will increase the tariff. And the signal will come to you, you better reduce it, otherwise your cost will go up like anything. And when there is a excess, the tariff will go down, and use that to try to increase the power consumption. Now, of course, this can be done quite easily at a corporate level, in factories, little more difficult at homes, but even in homes, a lot of thing can be done. So this work has gone on and has gone somewhere. Of course, one more alternative, which was not possible earlier, so therefore was not considered, but in recent times have become possible, is you store the electricity. Now, how do you store the electricity? Now, electricity can be stored when you convert it to something else, some other form of energy. Now, and then store it. So, when you take the electricity, there is excess electricity, you convert it in some other form, store it, there is some losses. You convert it back, there are again losses. For example, in a hydel power plant, you pump the water up from below. When water is pumped up, you consume electricity, and the water is now gone up. When you want to use the electricity, let the water fall. Now, of course, this has 30 to 35% losses. There has been a lot of work on this mechanical flywheels, which will store the energy. Just very heavy ones will just start rotating. The question is, how long can we store? If once you have stored it, is it not going to naturally die down? That is a concern. Conversion to hydrogen. You convert it to hydrogen and then convert hydrogen back to electricity. There are lots of experiments going on. The simplest one all of us know is use electrical, or what I call chemical batteries. Store it in lead acid battery, store it in lithium ion battery. There are many other kind of batteries, solid state batteries and other batteries. So today, in fact, it is the battery storage, that chemical storage in some manner, or electrical storage, whatever you want to call it, is becoming very, very common and popular. Most of our homes have inverters, which actually store energy when it is available, and if there is a power cuts, it gives you the power. Now, when you use this storage of any kind, you have to worry about what is the storage cost. Kilowatt hour is 1 unit of electricity. If I want to store 1,000 units, how much will I have to invest? The capital cost. And the capital cost, you have to then worry about what is the depreciation and interest rate. How long will that capital, that storage will last? How many years will it last? How many times I'll be able to, and what is the interest rate that I have to pay for that capital? So depreciation. How many times it can be used? How many cycles it can be used? Can it be used indefinitely, or after 10,000 cycles or 2,000 cycles, you need to change that. So that your depreciation will depend on that. Is there any cost per usage cycle? Are there operation costs? When I store it and give it back, what is there an operation cost? Now, suppose you store it in a battery or any other form. How long will it stay? Or will it self-leak? Will there be decay? There's leakage. Now, all these together actually contribute to the total cost. So you then talk about effective cost per kilowatt hour of usage. What is the effective cost per kilowatt hour of usage? And here in this effective cost will include capital cost, depreciation, interest rate, number of cycle, operation cost, and decay or leakage. But it doesn't necessarily take into account environmental impact, toxicity, hazards, recyclability. So frankly speaking, you need to take that also into account. Now, what is today possible? Renewable energy in India costs about ₹2.50. With storage added to use when renewable is not available, total cost hour will add some amount. What is that amount? That extra amount that will be added instead of ₹2.50, if I also add storage, how much will it become? Will it be ₹3 extra? What will it be? Again, I'm pointing out it's the same factor. It depends on the cost of storage. It depends on the depreciation, interest rate, number of cycles. How many times will it be charged, discharged per day? Depends on how much, what is the kind of mix of renewable energy that I used. And as I pointed out, how many times will I use it per day? Now, we took some lithium ion batteries which are available today. These are today's batteries. They are not tomorrow's future batteries. And some of the better batteries, we selected it and we try to compute what is the cost of per kilowatt hour of storage. We took all the factors that I talked about into account, and suppose once a day you charge discharge and you took the lifetime of that, depreciation and interest rate. See what the cost comes out. If I use one cycle per day, if I use only interest, it depends heavily on interest rate. See this is 2% interest rate, this is 10% interest rate. In Europe and other places, you use 2% interest rate, the cost is only ₹3, ₹4, ₹3.50. But in India, it is more than 10%. So the cost becomes ₹6 and ₹7, or even ₹8 or ₹9. Suppose you are able to use 2 cycles per day. If with 2% interest, it goes down to ₹2.50. But with 10%, it's still high, not as high, but around ₹4.50, ₹5, ₹5.50. How much does all this add to? What I have done here, let us assume that we are getting energy from renewables. That is costing us ₹2.50. Let's assume 70% we use immediately and 30% is stored and used later on. The 30% used and stored and used later on per kilowatt hour will cost between ₹1.20 to ₹2 per unit, which means ₹2.50 totally will become ₹3.70 to ₹4.45. Now, most of you know that today, for example, industry pays ₹8, ₹9. Even at home, it is ₹6, ₹7. So this is not bad. Even storage, also it will cost only ₹3.70 to ₹4.40 or something like that. And I can then therefore generate all the energy through renewables and build large storage and ensure that I get 24/7 only renewable energy. This is possible at today's cost. I've computed the cost based on today's technology. Now, of course, I have assumed that only 30% of energy is used through the storage, 70% is directly used. One will say, no, what happens if the weather is bad and all that? And only 50% of the energy you are able to use directly and 50% the storage. Of course, cost will go up. But you know, if you are trying to build a nationwide grid and nationwide storage, it is not going to happen in one day. It will take 5 years. And in 5 years, the cost of batteries will fall down by 50%. That's what is happening. Because it will fall down, my cost will go down. So I am pointing out that at around ₹4 per unit, we can get as much electricity as you want through renewable sources. That is what is possible today. And as I pointed out, there were talk about rains and weather. I mean, Rajasthan has very little rain. And you can put enough solar there. you can put enough wind, and it is theoretically, I won't say theoretically, it is economically possible to convert everything into renewable energy today. This is the first part of the talk that I want to give. The second part of the talk is, that was electricity. We of course can use that electricity for cooking. It is being increasingly used, and there are now stuffs available which are extremely efficient, which can make this possible. We can have a distributed energy, solar energy, and use it. I'm not going to talk about it, but I'm going to talk the later part, which of course Mahesh Babu will elaborate. So electric vehicles. Now, one of the byproduct of this corona crisis has been, if you walk out today, the weather that you see, you have never seen weather like this, at least in last 20 years. Because our vehicles today gives huge pollution. And we are the pollution capital. We are the 14 of the 20 most polluted cities in the world. And we are importing all oil, and that is also destroying our economy. Now, I want to point out, which today is well known, few years back was not as well known, the electric vehicle is 4 times more energy efficient than an internal combustion engine vehicle. And it has 50 times less moving parts. So it is not going to wear out also. So that's what I'm pointing out, that it has a motor efficiency of excess of 90%, whereas internal combustion engines have 22, 23, 25%. So what is the reason why we can't do it? Now, the key thing is batteries, the energy storage, because that is what is going to be store the electricity, store it in the battery, put it in the vehicle, and then use it. If I look at the energy density of lithium-ion battery, which is by far the best and least cost battery today, it is about 250 to 300 watt-hour per kg. If I look at petrol, it is 9,000 watt-hour per kg. So I take 1 kg of petrol, I have 9 kilowatt-hour. I have only 300 watt-hour, 0.3 kilowatt-hour in the using the battery. Even if I take 4 times energy efficient, basically the petrol is still about 7 to 8, 9 times lighter. And that is the reason petrol has been used so much. So what do you do? And the point is, the cost of the battery is inversely related to its energy density. If energy density increases, then cost falls. Fortunately, energy density is continuously increasing. If you see, the energy density was 80 watt-hour per kg in 2011. It is close to 300 watt-hour per kg, and the cost has gone down from 800 to 100. This is going to further increase, and cost is going to further come down. It is that which will make EV battery weight to be not comparable to a petrol, but I'll say get better. And then we have to use slightly larger size battery to go about doing things. Now, the point is, India's auto segment is different from the rest of the world. We don't have mostly large cars that most of the other countries have. We have two-wheelers. Our 79% of our vehicles are two-wheelers. We have three-wheelers. We have small cars. 10 lakh, 5 lakh rupees car, 6 lakh rupees car, 4 lakh rupees car. And then we have, of course, buses. These are 98% of our vehicles are affordable. Very different from that in the West. Can we get all these things to become electrical? I'm sort of saying today you are starting to see them becoming competitive. And by 2030, enough technology development is taking place. Earlier than that, but 2030, I will say all the vehicles in India, affordable vehicles in India, will become electric. And they will meet the requirement, the costs will be comparable, and that they will be attractive, and people will start using it. And you will see acceleration of it from this point onwards, and Mahesh Babu can talk more about it. The one issue will come, what about batteries? Our batteries uses these materials which are imported today, and are we going to create waste out of this material? Now, I want to also point out that today it is possible to recycle batteries, lithium-ion batteries, with zero solid gaseous effluent. And the cost, it is highly cost effective. So there is no, of course, there is a lot, quite a bit of manual work involved in that, but there is no reason why India cannot become the capital of the world to do urban mining of actually taking old batteries and getting the material out and creating new batteries. So this is what is possible. So as far as I am concerned, I want to point out the electricity can be 100% renewable, and the vehicle can be 100% electric or near 100%. Cooking can very quickly move towards that. That is what is possible. It is going to happen. It requires a little more will. It requires a huge amount of technology development. None of these things is trivial. And I think India has the capability to do this technology development. I think with this I will end, and I think I have not taken more time than was required. Thank you very much.
Yeah, thank you very much, Professor. I think you gave a very good overview, and if you can just summarize in a minute, what was very, very prominent is that, which you really mentioned about is managing the usage, the flexible tariff. I think that's a very key point, and storage costs, and then operational costs as such. But then getting this to be all mostly affordable. I think that's what you really focused on, and thank you for that. And also, especially giving hopes that EV is going to be the future, and basically by 2030, most of all our affordable vehicles will become, EV will become the norm. And more so, as you rightly mentioned, the batteries, are the ones that are going to define. And we import almost everything to make batteries here. But then this also provides a great opportunity for India as a country, and for innovation, and also for many entrepreneurs, for them to be able to venture into this area. Thanks again, Professor, and we'll summarize again end of the session, and thanks for your time.